So I started talking after you said don't talk, but I am not very good at following instructions. Yes. Hi everyone. Do I need to do the introduction? Hi people that are watching on YouTube, aka me in about 6 hours. Today we're covering inference scaling for long context retrieval augmented generation. Retrieval augmented generation, it was introduced last year sometime or the year before, I can't remember. It's about getting external information and putting it in the context of a language model. And that increases the truthfulness of the generated answers because you have external knowledge that you're generating the answer with. Does anyone have any questions to how it works? Or everyone here sort of has a pretty good understanding about why retrieval augmented generation works?
Could you just please look for the bullets?
Okay, so I guess this is. Let's see if I have actually generated a thing here. This is like, I guess we can do here. So let's just forget about the drag part. Well, let's just focus on this. But like a retrieval augmented generation takes a query and then retrieves a document. And with the query, it goes and gets like an embedding vector of that query, and then this document retrieval often is like in a vector store, and so it gets like nearest neighbors to that query. It then appends or prepends that document to the input query in the large language model, and then the final answer can be generated. So that's retrieval augmented generation. The retrieval part is important because if you don't have the retrieval part, it ends up trying to generate the answer from weights, and that ends up being not very good when it comes to things that need to be up to date, like the news or like anything basically.
Email inbox.
Email inbox, yeah, stuff like that. This paper introduces two different flavors of RAG, which is demonstration-based RAG. So as well as RAG, there is a demonstration, so almost like end-shot prompting, where you have an example. You get the document retrieval, and then you do the generation. So this is RAG, but also with in-context learning. So end-shot prompting. Is everyone are people clear on what end-shot prompting is?
Not to clear that.
Okay, so end-shot prompting is give an example of end-shot prompting. End-shot prompting is basically, yeah, here we go. So we're giving the language model a question, and we're giving examples of different different shots. Okay. And so we're giving examples to the language model of what the type of answer that we want out.
It's a really academic way of saying giving it examples.
Yeah.
Okay.
And demonstration-based RAG is essentially this. Honestly, the fact that they ended up classifying this as something different seems to be a convenience for the paper, because if I was to implement RAG, I would be doing end-shot prompting anyway. The other method that gets introduced in here is called iterative, where with demonstration-based RAG, one of the problems that it ends up failing on are questions that are multi-step reasoning. So multi-step reasoning means that if you've got a question that is like, so this one here, where was the alma mater of Tesla's CEO founded? So the multi-step of this multi-step reasoning is you first need to find Tesla's CEO, which is Elon Musk, then find his alma mater, UPenn, and then find UPenn's founding location. This is difficult to do in one step because if you just do one retrieval, you might get Elon Musk. Maybe you would get UPenn, but like there are multiple steps in this. And so iter_drag asks the language model to sort of decompose this into different questions that it can ask. And then it's got this process where you then generate the subquery. And for this one, it would be like, who is Tesla's CEO? Number two would then be, you would retrieve a document on that. It would say that it's Elon Musk's CEO. And then you would then generate the intermediate answer. And then you would keep doing that until you got to a final answer. The multi-hop reasoning is what this paper focuses on quite a lot. And iter_drag is not something that I have seen a lot of before in RAG papers. I don't read a whole bunch of RAG papers. And so they're the two RAG methods that this paper introduces. I am going to go through like the prompt templates for these quickly. So here, drag, you can see that we've got a retrieved document, and then we have the example. So in the context, this has demonstrations as well as the context for the question. Where for iter_drag, we can see that with the prompts, we get generate follow-up questions using the format follow-up X, where X is the follow-up question, then answer each follow-up question using intermediate answer X, with X being the answer. This we can see that this, iteratively reprompting this, we can get to the answer instead of, and because once we generate the answer, we also do another RAG step to retrieve more documents. That is iter_drag. The reason why this is important is because this paper tries to calculate a law for if you have a language model that has a really, really, really large context length, how do you effectively use it? Do you have a lot of examples for end-shot prompting? Or do you use iterative prompting? So do you keep decomposing the questions? Or do you add more documents as data sources? Yes.
With the answer?
That was a break in my context length, and then it overflowed, and then the next token that I generated was yes. Cool. So that is that. Are there any questions around iter_drag, RAG, any of the other things?
I just asked a whole bunch of AIs. What city has the alma mater of Tesla CEO? Answer in one word, and I'll just photo. Yeah.
Sick. It's also that's a question in a data set.
Yeah.
And so it probably just got the question from the data set.
Okay, so if I change it to what?
They can a lot of steps. They can
Wait,
No.
Philadelphia?
Yeah, the problem is Elon Musk is all over the internet. You need to pick what's the some random company.
No, but maybe.
CognitionTO, let's go.
Doesn't it fail anything after 2021 or something?
No, not anymore.
And
Okay, so I switched it to Boeing, and it gave me the answer to Purdue CEO. Who's
Purdue.
yeah, give me the answer for a different, the right guy, but different company.
maybe he does both.
Well, they just got a new CEO.
Um,
Anyways, it's also I saw that too. Yeah, I was amused. Yeah. So was Purdue right for the past CEO or?
Did they swap CEOs for some unknown reason?
No,
Boeing has a lot of reasons.
Right?
Boeing has a lot of reasons about their CEO.
Oh, we're not, no, guys, stop talking about it. We're not allowed to talk about it, remember?
Oh.
Yeah.
Shh, shh.
I was just gonna go play on a few.
Oh, man.
Make sure it's an Airbus.
Being recorded.
I don't know how I can make sure of that, but I'll try. Oh, is anyone going to Europe by any chance? Did you end up going? Are you going to Europe?
They have like a lottery system for tickets. I didn't get it in time. Did you get a ticket?
Yeah, I got a ticket like 2-3 months ago or something.
Wait, when? That's fine. I'm going.
It's in Europe. Do you have tickets? That's great.
Yeah.
Cool. It's in December. Like 9 to 15.
I'll need to check.
That's
If
great.
anyone would like to donate me a ticket, I will go.
Yeah.
I can't do that. I can barely donate myself a ticket, but.
Okay.
But if anyone's in Vancouver in the week of the 9th.
It will be a Vancouver.
Sorry? That's great. We should hang out.
We should.
How do people? So, from people that have been in this session before, which are, I guess, you two, do you think that we should read through the abstract and introduction, or should I just go over the key findings? Any preference?
Abstract.
Abstract. Okay, let's do abstract. The scaling of inference computation has unlocked the potential of long-range context, large language models, LLMs, across diverse settings. For knowledge-intensive tasks, the increased compute is often allocated to incorporate more external knowledge. However, without effectively utilizing such knowledge, solely expanding context does not always enhance performance. In this work, we investigate inference scaling for retrieval augmented generation, RAG, exploring strategies beyond simply increasing the quantity of knowledge. We focus on 2 inference scaling techniques, in-context learning and iterative prompting, which is what I was telling you about DRAG and iterative DRAG. These strategies provide additional flexibility to scale test time computation, e.g. by increasing retrieved documents or generation steps, thereby enhancing LLM's ability to effectively acquire and utilize contextual information. We address 2 key questions. How does RAG performance benefit from the scaling of inference time compute when optimally configured? And 2, can we predict the optimal test time compute allocation for a given budget by modeling the relationship between RAG performance and inference parameters? This is saying that the scaling of inference computation or test time compute is essentially if we have a model with a large context window, and like, can we just like use more compute at inference time to generate a better answer? Like we went through last week, this is also a thing. This like O1 was a big breakthrough on this. More difficult questions can end up using more compute at like inference time, and you end up getting a better answer. Modeling the like for a given budget by modeling the relationship between RAG performance and inference parameters, this is essentially saying like the trade-off between in-context learning, iterative prompting, and a whole bunch of other stuff. Like, can we retrieve the optimal amount of documents to make our model generate the best answer? Our observations reveal that increasing inference computation leads to nearly linear gains in RAG performance when optimally allocated, a relationship we describe as the inference scaling laws for RAG. Building on this, we further develop computation allocation model to estimate RAG performance across different inference configurations. The model predicts optimal inference parameters under various computational constraints, which align closely with experimental results. By applying these optimal configurations, we demonstrate that scaling inference compute on long context LLMs achieves up to a 58.9% gains on benchmark datasets compared to standard RAG. Yeah, this doesn't really go into a whole bunch of detail about how they do it, but essentially what this paper is doing is we have a particular token budget, like 18K, 128K, 1 million. What is the best way that we can use that token budget to generate our final answer?
Just for a minute perspective, like a 400-page book, like an average book, is probably around 100,000 tokens. So we're talking about like a context length of 100,000 or 1,000,000, like that's like 1 or 10 books at a time that it's thinking about.
Yeah. I'm going to go through the introduction. I think that's a good idea. And we will then go through this diagram here. And then I think we're going to skip to the inference scaling strategies. Introduction. Long context large language models, LLMs, are designed to handle extended input sequences, enabling them to process and understand longer contexts. Gemini 1.5 Pro with 2 million tokens. Combined with increased inference computation, long context LLMs demonstrate improved performance across various downstream tasks. For example, many shot in context learning can match the performance of supervised fine-tuning by providing extensive in-context examples, particularly for knowledge-intensive tasks that leverage retrieval augmented generation. Increasing the quantity or size of retrieved documents up to certain threshold consistently enhances the performance. You give it more examples, it does better. It can also match fine-tuning, essentially. Previous studies on inference scaling for RAG focuses on expanding the retrieved knowledge by increasing the number or length of retrieved documents. However, only emphasizing the knowledge quantity without providing further guidance presents certain limitations. On one hand, current long context LLMs still have limited ability to effectively locate relevant information in the ultra long sequence upon challenging tasks. This is interesting because with the really long context language models like Gemini, one of the ways that they end up achieving such a long context is by using things like compressive memory, which are like it essentially compresses the knowledge in a part or like the start of the context and sort of pulls it through to the end of the context, sort of like an RNN, essentially saying that when you scale up the amount of information that you have in these really long contexts, it doesn't actually really work like as you expect it with just scaling up the context window. And there are limitations to this. Another problem that ends up happening is the more irrelevant information you have in your context window, the more the model gets confused. And that's sort of expected. So the more documents that you've got, the more irrelevant information, your model can also get confused.
What if that's something you could train a little further on? They train it to discern what's important or not. Sounds hard.
No, you have reward models you can do that with. That's kind of part of the other scaling laws paper, right? Yeah, did you guys cover that?
The chinchilla optimal.
Yeah, I think that's the same paper. But either way, like what they were doing was like at each reward or at each reasoning step, having a reward model evaluate that, right?
Oh,
So
yeah.
you can do that with like documents as well. Like have a reward model evaluate if this document is relevant, give it a score, and filter out documents that way.
The problem, yeah, the problem with this is that I guess it's very difficult to the paper that we read the first time, which was understanding limitations of mathematical reasoning in large language models, the math paper by Apple, sort of shows that if you add irrelevant statements into it, like it's very difficult for the language model to ignore things that are there because it's going to draw conclusions from it.
Yeah.
And fundamentally, like training out irrelevant data is really difficult to do. So yeah.
So I think in that case, you would need like an external model to help filter it out, or
Yeah.
like you need an external process to filter out irrelevant data. It can't like be trained in.
And a really good embedding model with like query rewriters and re-rankers and everything.
Yeah. Speaking of re-rankers, I'm surprised they don't talk about that.
Yes, that is surprising in this paper, honestly. I did think that as well. So this figure 1 is normalized performance versus effective context length of QE, CQ, whatever that is.
Music.
Music. Nice. Each line represents a fixed configuration scaled by adjusting the number of documents. Red dots and dashed lines represent the optimal configurations and their fitting results. Standard RAG plateaus early at 10 to the 4 tokens. In contrast, DRAG and iterag shows near linear improvement as the effective context length grows. So what we can see on the left here, as you increase the effective context length from like 10 to the 4 or even 10 to the 3 to 10 to the 4, the performance doesn't actually increase very much. And this is essentially because we're just adding more irrelevant documents to the context, and the model isn't really able to generate more correct answers. As opposed to DRAG and iterag, one of the things that's interesting about this is DRAG is essentially just RAG with examples and shot prompting, where we can see that this plateaus off pretty early, but as your effective context length increases, it then becomes more beneficial for the model to like decompose the questions and use the context length up by decomposing the questions and then like iteratively reprompting on further questions.
We should talk about what effective context length is.
Yeah. I was curious.
Yeah, the effective context length is here. So building on these I'm going to read through the rest of this. Effective context length is essentially like in the iterative reprompting example, it's the amount of tokens you used up for the entire question, because you're iteratively reprompting it and you have RAG steps within that. So it's like all of those tokens together. Yeah.
But what about just the regular RAG? Or like
The regular RAG, then the iterative like reprompting is set to 0, and so then it's just the context length of the model or of the question.
Does that left chart end where it does? Because that's the whole context length. It's
10
on
to the 5.
no, it's on a log scale, so that's close. The next notch up is like is it 128K? Is that where that is?
What's the question? Wait, with
The question is why is the last dot where it is? And is that because that's
this one, the red one?
the next one? That, yeah.
I don't know.
Is that because they're doing RAG in the entire context length? Is that what that is?
I'm not sure.
Because the one of the obvious things here is that the RAG doesn't use as much effective context length, especially as iterag. But somehow the DRAG also goes a little bit farther too.
Oh, like here.
Yeah.
That might. I'm not sure. Like, why is this level over here more than this level over here?
Well, I think where it says Agrawal and all, it says that you can achieve what was it? The optimal performance without utilizing the maximum length. So maybe they checked already and going further doesn't.
Yeah, I will read on. Let's see if it comes up. For instance, the optimal performance of long context LLMs is often achieved without fully utilizing the maximum length. On the other hand, numerous studies show that retrieving over soft thresholds, e.g. top 10 documents, leads to a performance plateau and may even cause declines. Such performance drop may be traced to the increased noise within context, which causes distraction and adversely affects generation. As a result, inference scaling of long context RAG remains challenging for existing methods. In this work, we leverage a broader range of strategies to comprehensively explore how RAG benefits from the scaling of inference computation. A straightforward strategy is demonstration-based RAG, DRAG, where multiple RAG examples are provided as demonstrations to utilize the long context capabilities of LLMs. DRAG allows models to learn in context how to locate relevant information and apply it to the response generation. Nevertheless, the quality of one-step retrieval varies across tasks and often fails to provide sufficient information. Inspired by iterative methods, we develop iterative demonstration-based RAG, iterative. Iterative learns to decompose input queries into simpler subqueries and answer them using interleaved retrieval. By iteratively retrieving and generating upon subqueries, LLMs construct reasoning chains that bridge the compositionality gap for multi-hop queries. Together, these strategies provide additional flexibility in scaling inference computation for RAG, allowing long context LLMs to more effectively address complex knowledge-intensive queries.
Today, the word of the day is compositionality.
Compositionality, indeed.
Word of the day.
Yeah. Continuing on, building on these strategies, we investigate multiple ways to scale up inference computation. Here we measure computation by considering the total number of input tokens across all iterations, referred to as the effective context length. So that is the effective context length, the total number of input tokens across all iterations. In drag, this would be just the context length. In iterative drag, it would be every single question and answer that comes that gets generated before, like including the final response and everything.
That's interesting.
Yeah.
Doesn't look like it does. They say it only includes the input tokens. It doesn't look like it includes the output. But I guess it is an input token to the next question.
Yeah, I would say. I think I would say that.
But doesn't it, like any iterative process will have like way more input tokens in general, like if you're iterating like several times. So
Yeah.
I don't, like if you're just comparing, like I guess I don't follow the graph is what I'm kind of confused about. Because if you, I mean, maybe that's why it's shrunk on the x-axis the way that you were describing earlier, like lines don't go as far to the right. It's because maybe there's actually like just that limit of, you know, context length, right? Whereas iteratively, you can add more and more input tokens. You can keep iterating as long as you know.
Yeah.
Maybe that's what that is, but.
Yeah. Let's see. In drag scaling, the effective context length can be done by increasing two inference parameters: the number of retrieved documents and in-context examples. In iterdrag, test time can be further extended by introducing additional generation steps. Since different combinations of inference parameters result in varied allocations of computational resources, our goal is to establish the relationship between RAG performance, different scales and allocations of inference computation. Through extensive experiments on benchmark QA datasets, we demonstrate that an almost linear relationship between RAG performance and the scale of effective context length by combining both RAG strategies. As shown in figure 1, right, moreover, our RAG strategies exhibit improved performance than merely scaling the number of documents, achieving state-of-the-art performance with the compact Gemini 1.5 Flash. So this is all of these questions, data benchmarked are multi-step reasoning questions. So again, think of like, you know, Elon Musk, who's the where is the alma mater of Tesla located? It needs to do all those reasoning steps. So RAG here is sort of the benchmark. We can see that many shot QA wouldn't really help that much over zero shot because we need to be able to do like retrieve data. RAG helps a little bit, and that can be because it's getting any useful data. Maybe it knows that Elon Musk is from like when is the CEO of Tesla, but it can't do any more generation steps. Drag increases a little bit on that. Don't, I guess, for the same reason. Iter increases even more on that because it is allowed to do a whole bunch of more steps. And I guess this is one of the big findings of this paper, another prompting method which allows for it to have really good results on
So-
a not very good model, which is Gemini 1.5 Flash.
So I got this straight. Drag is drag plus many shot key, right?
Yeah, I guess so.
And then iter drag is drag, but it's not trying to answer the question the first time. It's trying to break down the question and then answer that and then use that to break down the question again.
Yeah. And then when it gets to the final answer, or it thinks that it's confident enough to generate the final answer, it then takes all those previous answers and then generates the final answer.
I think importantly as well, though, like each intermediate answer is passed to the subquery of the next one. So it's very much iterative in that regard. Yeah.
So that's just chain of thought then.
Right.
Yeah. Well, interestingly enough, there is actually a chain of thought thing in here, which I didn't really understand what the chain of thought doesn't have RAG. So it's like chain of thought with RAG in between all of the steps.
It may not even be a subquery, like taking the question and breaking it into different questions may be necessary, but it may not be necessary, and you can still do an iterative thing with that. What I mean by that is you can actually have like an agentic thing, like where you have like a question, you ask it for the answer, and then you ask it again, evaluate this question answer, doesn't make sense. If it makes sense, yes, and then you cut your process there, and you say no, then you keep going. So in those cases, there wouldn't necessarily be subqueries generated or something. So there's like a few, I'm not sure, I think this paper focuses on subqueries, but I don't know. But it doesn't necessarily mean there's questions all the time. Sometimes it's just a loop of like, can you improve this answer or something?
Well, I mean, we can look at the iter drag.
Yeah, the diagram's really helpful, I think.
Sure.
Which one?
Oh, the iter drag diagram.
This one here.
Oh, no, the one in the paper.
The one, yes, right. This one.
Yeah.
Yes. So drag being you have your in context examples, which end shot prompting essentially with your documents, and then you have your input query, and drag just takes that to the final answer. Whereas if you then follow this input query that generates a subquery, like who is the CEO of Tesla or founder of Tesla or whatever, then it retrieves and generates in between there. You get an intermediate answer. And I guess this arrow here implies that the answer of the last question can also lead on to other questions, subqueries. Whereas I guess with chain of thought, you have the same thing, but you don't have this retrieve and generate step in here. So that's
just like querying the LLM again.
it's querying the LLM again, but you're also doing a retrieve step.
Yeah.
Yeah.
No, I meant with like chain of thought. You're basically breaking down the question and then.
Yeah. And then
trying to
answering the
answer.
question with in weights
Mhm.
without having any external data to
Yeah.
to.
So basically, it's like the process is kind of the same, but the way you're querying it kind of changes. Now
Yeah.
it's like retrieval and
Yeah.
generation as well.
Yeah, so we have that. I am going to skip over all of this because I don't think it's very useful. Related work, we've gone through long context LLMs. In context learning is just putting stuff in the context. Retrieval augmentation, augmented generation, we've already done that. And so we have also gone over the base examples of demonstration-based drag and iterative demonstration-based drag. I don't think that is very useful, so I'm going to skip over that. we have gone through this diagram here, which is also not too, yeah, we went through that. One of the things that's interesting about this is the part in our implementation, we allow up to 5 iterations of query decomposition before generating the final answer. So it doesn't matter how long the context is. There are always, I guess it does matter. They do, this is a parameter that they end up like looking at and changing.
Josh, if you go up to the diagram,
Yeah,
you notice each of the subqueries does a retrieve step as
Yeah,
well.
yeah.
So I think that's also how they scale the effective context. Is at each of those retrieve steps, you can retrieve more and more documents, for example. than
Right. And so these retrieve steps doesn't just have one document that's retrieved. They can retrieve like 100 documents in between every every step. Yeah. That makes sense. I'm not going to go through the math because the math is essentially a way of drawing a line on the diagram. So we're just going to end up looking at the diagram. Last time I ended up going through the formulas, I almost fell asleep as well as I think everyone else. But I guess one of the things that's just this first part, which is for a given budget on inference computation, i.e. maximum effective context length, Lmax, there are multiple ways to optimize the use of computational resources through inference parameters. For example, in drag, we can adjust both the number of retrieved documents and in-context examples, while in the iter-drag strategy, we additionally introduce the number of iterations for retrieval and generation. Henceforth, we use theta to denote all these inference parameters. So we've got a lot of knobs that we can adjust to increase this. This formula is essentially like a sweep over all of the parameters to find the maximum performance. But I'm not going to go into that. One of the things that is interesting is getting to the results table. So we have optimal performance on different methods with varying maximum effective context length, Lmax, i.e. the total number of input tokens across all iterations. QA, ZSQA, and MSQA refers to zero shot and QA and many shot QA respectively. Partial results are emitted for each method that do not further scale with increasing Lmax. For clarity, we marked the best results for each Lmax in bold. So the thing to know here is we can see that as Lmax increases, so we're getting like either we're using more tokens. We get the model, the performance sort of is good with drag to start off with the smaller token budget. But then as we increase our token budget to 1 million and 5 million, iter-drag ends up beating out drag across everything. This makes sense because when you have a smaller token budget, getting more documents in general is a pretty good strategy. But then when you get the ability to have more of a token budget, breaking down the task and then doing RAG ends up being more effective at like actually retrieving the correct tokens and everything.
What happens if it hits the token budget? Does it just give up iter-drag?
I think that's a good point. I'm not exactly sure. I think it might. How do they do the token budget?
They say Lmax, it doesn't mean maybe like it's a limit, you know?
Yeah.
A limit on.
They I think this is a sweep of they change the parameters and then they see what the maximum like budget is for those parameters. So it's more of like an end case as opposed to a thing that they did themselves.
That was part of the like findings that they were looking for, right? To like how to best optimally use the like context window that you have, basically.
Yes. Yes. Yeah. So if we go to this formula, it's sort of like we're trying to find the maximum, the optimal metric P. And we're trying to change, like, make sure that the generation steps in that is less than our L max. And so we're sort of from that, then these would be, these would end up being like limits on here, I guess. I'm trying to think if that makes sense. Where is it? Yeah,
The red dots in the graph, I think, are supposed to be their like computed model, like performance, basically, that they hope to aim for. I think that's what we're saying.
well, that's the highest downstream performance on a particular, like on a particular context length. So like they'll change the number of documents retrieved and the number of generation steps and the number of examples. And then when it then finally answers the question, they'll then count up the amount of tokens generated and then plot it on this graph. And the optimal config will be one of those, like one of these lines essentially. Yeah, and then they're getting the law for that line that describes how good that is. Where are you guys going?
We forgot drinks.
Oh, cool.
But rather, you could, yeah.
Oh, yeah, would people like pizza? We're gonna take a break. It's pizza time. That's the name that I was meant to say.
Be pausing the live stream while we eat or what?
Historically, no, we just kind of, if it pauses, it'll time out on the YouTube side.
Oh, really?
I think so.
Wait, we're live stream on YouTube.
Let me show you.
Yeah, you're such a friend of
How do we find the stream?
I think it's like cognition.
CognitionTO on
Is it
YouTube.
TO or
TO.
TO?
Why? Every time I come up with a name with something, you question it, and I'm like, Melanie's right. It doesn't make sense. Can you stop?
TO. It is TO, right? Yeah. I guess either could work. How are you?
I'm great. I'm amazing.
Thank you for letting me.
One.
Oh, crush this. Yeah. No problem. Yeah, just doing that.
And the only one you.
But just for like.
Where's Alex, by the way?
Oh, yes. Good enough.
Yeah.
Yeah.
Are you working for Deloitte soon or not? Meet, I forgot your name. Trey, meet Pavel,
Hey,
meet
nice to
Trey.
meet you.
How's it going?
Pavel might be working for Deloitte soon.
Oh, very nice.
Yeah, I got a verbal offer, but like apparently their hiring team is all on vacation, like on HR site. So you tell me, are they actually on vacation? What's going
I
on?
don't know them. Give me their name. I
Give
can
her
find
a
it.
go for this. What are you doing?
No,
Been
actually,
here for 2 months.
Really? What do you do?
Right now I'm doing strategy consulting, but I'm moving into the Gen AI office in January. So,
Nice.
yeah, so
You're an engineer?
I am, yeah, so
Which one?
computer,
Awesome.
yeah, so like there was a big restructure. It's like, I was here for an internship for 15 months,
Uh-huh.
and I went back to school, finished on my degree,
Right.
and then I came back and big restructuring. And then in the restructuring, I got put in the wrong place. So I'm doing like,
Heard about that recently, like it was a big thing.
yeah, it was like a pretty big,
Systems and it.
yeah, so I came back and I didn't know what was going on and
Great thing.
people didn't have a ton of answers for me, so.
Simple right now, because it's like a friendly, yes, we love you, come join us, and then, well, like
Yeah.
sign the paperwork already, like, what is happening?
It's ridiculous.
Yeah.
But like, I don't know, it all ended up working out and then
Yeah.
kind of found my way back to more so what I wanted eventually. So, I mean, that is the good thing. Josh about that. That is the good thing about the one is that they do like everything. So if you want to do something else, you can just get them way in or something. So,
Okay.
I've seen
where
are you joining Red Live over the time?
Genial.
oh yeah.
I a little bit. Heavy.
That is,
Yeah, you need to totally back out of office,
Yeah,
email stuff.
Yeah, that was, I think.
Exactly, like, I
Get Trey
Yeah.
to send the hiring,
Well-
you should, you know what you should do?
Yeah, I mean,
You should
send
set
it
her,
to
you should set her up as a referral and then became the hiring manager, because she's already got verbal offer, because she doesn't have an action.
Wait, what? Whatever you do.
And then you get free money and she.
Oh
gets
my
it.
God, yes. You know,
I don't know if we could do that, but if we could.
It's fine. This conversation isn't being recorded. It's
Oh,
completely
if
fine.
you split your money with me, then yes, whatever you say.
You got a job. You don't get it.
Hey.
You split the money with me because I came up.
Josh.
Oh,
Okay,
did you say, or did Josh say you have a verbal offer?
But Deloitte, yeah, but I mean, they're taking too long to get back to me, and we'll see where we land, I guess, at this point.
It's fine. We can pass to Alex.
Yeah.
Maybe I move to
Maybe
New
that's
York,
what
who knows?
Pass is ahead of that division, right? We can.
People listening
Well,
a lot better than they listen to me.
That division doesn't have a problem with me, it's HR. That division has passed me already.
Like you haven't even been hired yet, and you haven't even had your first day yet. You've already got a problem with HR.
But they have a problem with me, not the other way. I'm asking them. to
What
come
did
back.
what did you do?
Who knows?
When you
Can I move this back?
start,
Yeah.
or
Oh,
No, it's just saying, yeah, it's probably vacation, and honestly, you know, like, it's still time of the year right now, so it's
Right.
probably better to go in later.
Josh,
yeah. How's it going?
did you order these pizzas?
Is
Do you
it,
have complaints?
I have thoughts.
What are the thoughts?
My thoughts are surrounding the toppings of olives and mushrooms.
oh, good, that's good.
Hmm?
That's good.
I'm
It's
sorry.
good that I have thoughts.
I'm sorry. I'm sorry, Anthony. Are you getting free pizza?
I hope you.
And then complaining about it.
Hey,
I will. Yes.
I'm trying to save, I'm just trying to save the org money.
Thank you for the. Alex paying for it actually. So please don't complain to him. Please don't complain to me instead. We're very thankful for Deloitte. Thank you very much, Alex. He's not going to be watching this stream.
Oh.
so-
But is it still streaming?
Yeah, it's still in the corner.
You should. offer
Mic is
something
off,
to
mic
the
is off,
camera.
right?
It shows the mic is on or not. I think the mic is on.
Oh.
One of the mics on.
Oh, no.
I'm okay.
Yeah, this building is delightful.
Hey.
That was good.
Do we do introductions or something? about-
Yeah. Let's. That's a great idea. I'm Josh, by the way. I'll go if I introduce myself.
Nice to meet you, Josh.
Hi, Paho.
Hi, Josh.
What am I? I'm from Australia. I've been in here for 2.5 years, which is great. I recently got permanent residency, which is great. So
And you're already planning to go back to Australia?
I'm already planning to go back to
Running away.
Australia. Only because it's getting cold in Toronto. If it wasn't that, I would be like, Toronto's the best, which I was a couple months ago.
and this was like the warmest fall ever.
Mm-hmm.
Yeah.
That is true. I have been told that I'm a little bitch by a lot of people, but that's about it.
Even regular snowbirds aren't flying this year. It's literally so warm.
Really
Yeah.
interesting. Would you like to introduce yourself?
After I finish chewing, yes.
Okay. Would anyone else would Jasper, other
Okay.
Australian?
The other fellow Australian here. I'm Jasper, software engineer, working on an AI safety research paper in the co-working space with Josh as well.
I've actually technically been booted for now, but
What?
You have?
How do you get booted?
no, there's just too many people for the amount of we work see. Well, technically I'm not part of it,
There's
but
basically no one in the
I'm
office today.
really? Oh, I was in the office today. I was on level 5.
Oh, okay. Great.
I'll go next. I'm Smitty. I'm a software engineer. Right now I work on a vector database, and I like AI and stuff.
Are
I also like AI and stuff.
you also a software engineer?
Hmm?
Are you also a software engineer?
Me?
How many software engineers in a row?
Nor data scientist.
Oh,
What am I at this point? Oh, I didn't introduce myself. Hi, everyone. I'm Pahul.
hi, Paho.
Hi. I am a machine learning engineer, hence my question that I don't know if I'm a software engineer or not anymore, like what even is a software engineer? So yeah, so I work with pricing, tons of Gen AI work, and more so things related to e-commerce and all of the product and customer and mostly pricing related stuff. And I'm here because I know Josh and
That is true.
I was actually one of the first members of the paper reading group when I was
Yes.
at his couch, and I
Yes.
would always fall asleep.
Yeah.
And we needed this help.
Which now all of a sudden I'm like, why are you even interested in coming? Like, do you just want me? I can just come over to your house and then like sing you lullabies and then you can fall asleep. Yeah, we don't need
No,
to
give me blankets and a couch. What am I supposed to do?
That is true.
Yeah, that's very like go to sleep vibes. Like
Exactly.
Yeah.
It's a
So
fun-
I'm grateful for this place where I can't fall asleep.
Pavel is going to Taylor Swift this month. So that's exciting.
Yes.
I have a friend who's downstairs. Can I bring him back down?
Is he on the? Did he register?
Hey, did you register?
Or what?
Yeah.
What's his name?
It's a register.
Is it in the stack of? I don't think we're allowed to leave.
Yeah, I think the Deloitte employee needs to accompany.
I would
Yeah,
prefer
it needs to be a company. It needs to have our hands on.
Send Alex.
You can go there, can't you?
Not to go.
Yeah, but I think I got a babysitter, you guys.
Oh, right. So we might.
In mental
Yeah,
health.
you might exit the. Yes. Thank you.
In
Thank
mental
you.
health.
Thank you for babysitting us.
Yeah, hi.
No, it makes sense. It makes sense.
Okay.
I don't
I
want
trust you guys.
I don't want to sabotage our space. I also don't want to sabotage your job. So let's
Yeah.
follow the rules.
Like the job for now.
If we can call out us from somewhere.
That's a good point.
Luckily, I think the Deloitte employee should be back soon.
Yeah.
Yeah, I'm paying him right now, just so he can.
What vector do you use?
PG vector scale, which is like an extension to PG vector.
Yeah. Okay, is that open source?
Yeah.
Awesome. That's really dope. You work for like, you're just like open sourcing it, is that your, or like, is it somehow your job also?
That's my full time job.
Oh,
Should be back. If you see.
So is there a Postgres?
Does he know
that
Chris?
saves people?
No, so PG vector, like I don't work on PG vector proper, I work on PG vector scale, which kind of
No.
like, to that is scale which develops in like.
You see.
Oh, scale,
Yeah.
that makes so much sense.
People coming back.
Yeah.
Yeah.
Very nice.
It's like a more efficient variable algorithm. for
What?
PG vector.
Yeah, okay.
Reading.
And like.
I'm not even a math.
Okay, so they're saying just wait.
Or are you like you need
And,
It's
how's
good. I like
it,
pizza.
how's it more efficient? You think? What are some of the,
Especially when it's free.
what's like the main value prop?
So we just use a completely
Yeah.
different
So,
way of
come down and get.
indexing the vectors in
Okay,
the vector
that's
dive.
here.
We use
Sure.
disk ANN, which is, it's hard to explain, you just read the disk ANN paper.
Sure.
Hi, Smitty.
I just said the name of like, maybe you could do a paper reading session about disk ANN.
What?
Do you want to present one?
Maybe.
Oh yeah, I'm not with these sessions. Like, if anyone wants to present a paper or wants to go through something, or
Alright.
like, we're up for it.
Okay.
Yeah.
Wait, what's your friend's name?
Good.
Okay, that's the guy who invited me.
Oh, Skype.
Yeah.
Yeah, and he didn't register.
Oh, he
Yeah,
did.
he did. Oh, you
Oh,
did?
if you registered, then the thing's probably here.
Yeah, no, I was asking, can I bring it down to him? Is that okay?
We're not allowed to leave this room,
Oh, I see.
but when Alex is back, yes. Oh, but Alex doesn't have his pass. So Alex is going to pass him on the way up.
They just got a temporary badge wearing that badge. I don't know, substituting.
That is true.
There's also a problem with the Deloitte badge readers right now. They're doing a firmware update on all of the badge readers downstairs. So you have to go a bit of a roundabout way to get here. That's why I was delayed.
Oh, interesting. Very interesting.
Oh, I guess I'll introduce myself.
Yes.
Hey, my name is Amar. I'm probably the only one that's not engineer related. I work in politics.
Oh, cool.
Yeah, but I met. I call him V. Met him once, so I met V, and he's told me to come through because we were just talking a lot about, AI and just different tech stuff, and then he blew my brain with everything he taught me. So he's like, "Oh, you should come to this place. You learn so much." And so far, that's been the case. Yeah, I really learned quite a bit. So yeah, just here, like,
That's cool. Is there like fields within AI or research or anything that you're interested in with, like, is it related to your job? Or is this just an intellectual curiosity?
I would say mostly intellectual curiosity. I mean, there's like small cases where we look into this stuff, we really, like, not to this level at all. Like, how many people making the rules know about half the stuff, which is actually a problem. So
Yeah.
at least they're a bit-
Imagine the government's like, actually, you can't iterate 5 times to retrieve any step. That's
Yeah.
not allowed.
I wouldn't be surprised if they do.
That could happen, right?
Right.
It's
Which
actually
happened in California, though.
All it would take is one convincing lobbyist, I feel like. Actually, this is too powerful. It's AGI. Now we need to regulate it.
Yeah,
Are you federal or provincial?
federal.
Okay.
Will probably be out of a job.
Yeah, I was about to say, but I was gonna say.
Yeah.
My sister's also in the
Oh, yeah?
government. Yeah, similar story. Yeah, everyone's gonna be out of a job. It's tough.
There
Are you
was,
permanent or
Mhm.
okay.
Well,
No, you're safe then.
no, like I'm part of like, not permanent, like I'm part of the current government's people.
Okay. Okay.
It's permanent, but not for how long we don't know.
there was this paper that I found really interesting because they ended up like simulating diplomacy with language models.
Simulating the. No, I need it.
Mm.
You have Serbia and Rome.
Yeah,
Why have I never seen this one?
it's like they were
Are they
playing,
fighting a war?
like Civilization or something, but with language models.
That's so fun.
Yeah,
Even though like one where you're like.
It's a middle. It's meta.
Yeah.
Is this like a paper or?
Oh, it's Cicero, right? I saw this on Twitter.
this was a while ago.
Yeah.
I don't know if they've done an update.
I think Meta always makes it.
2022.
Yeah. Oh, Meta is like probably the
Um,
top AI lab right now.
I am not sure, but yeah, it was just interesting because like,
Curious game theory.
yeah, you can just like simulate a whole bunch of different diplomatic scenarios and everything. And I find this to be really interesting because like if you can do that, you can also do like simulations of like organizational policies and whatnot, and like
Yeah.
actual interactions between people and everything, which is interesting. Yeah.
Did they ever declare war on
They
it?
said it was what 90.
I'm not sure.
They go to war in Russia in winter.
Did they ever declare? You think the next world war is declared by AI?
I don't think we need AI for it.
Really? We could do it on our phone.
Yeah.
They haven't done an update in a while, but I wonder if that would be a thing. Anyway, that was fun. I think I will, wait, you guys haven't introduced each other, yourselves.
David,
Hi, David.
you want to go first?
Go first.
Yeah, I have a background in computer vision, and right now I'm working on an AI chatbot, voice agent that you can use to trade crypto.
Awesome.
The hype there, you got the AI hype, blockchain hype. Computer vision hype, a good intersection of computer vision.
Are you also going to a Taylor Swift concert this month?
You know what? There's gonna be like 2,000 people just at my friend's condo, so.
What?
Like staying there. Yeah.
What?
Can I find a place to stay?
All the Airbnbs.
All the
are sold out.
Airbnbs, yeah.
Yeah, but who has a place that can fit 2,000 people?
Oh.
No, I mean like in the one building. Like a mix of.
Yeah.
Oh, I should have rented mine. I have time to charge. I think there's one more guy in the lobby, but I sent you a message, but I can go grab him.
You wanna go grab it?
Bithrin, right?
Yeah. Right.
Okay, cheers. Sorry. Forgot drinks.
No problem. Thank you very much.
Cool.
Yeah, sugar water and.
Thank you for the pizza, Alex.
Cheers.
Thank you.
Enjoy. Good.
Do we need to have a thanking the sponsors segment in this paper? Because we can't. Are you guys hiring?
In certain jobs, yes.
Well, if you guys would like to work for a really great organization, Deloitte is hiring in certain jobs at the moment. So visit,
Jobs.
yes. So visit Deloitte.com/careers to start your career.
I did not pay him to say that.
You pay me.
That's not how you plug your sponsor though. Deloitte's a consulting firm. You say, do you have any consulting needs, government
Oh,
employee?
that's what, that is true. Yes.
I am just helping him out sponsor.
Now he's been taking
With a
pride in
space.
pizza slices.
I had nothing to gain from this.
And there's video evidence of it.
I want you to have something to gain from this though, because then I feel like I'm adding value. I don't even get paid by Deloitte. Why do I care? Okay, so getting back to, we didn't continue the introductions. We're doing some quick rounds of introductions before we start.
I guess I'll go next. So hi, I'm Ali.
Hi,
Originally, I'm from like the neuroscience space,
Oh,
and now I'm like in the bioinformatics space.
I've got so many things to ask you about so many different things because yes, that sounds awesome.
Absolutely.
My name is Tim. I'm a software engineer.
Nice.
Right now, I'm focusing on DevOps primarily. But you can't develop software without AI these days.
That's true. What's your favorite Taylor Swift song?
I'm not going on the control.
Oh no.
Aww.
Wait, is blank space?
Yes, that is.
Okay,
that's a good one.
Yeah.
My one's New Romantics, if anyone was interested in knowing, but
Is that a newer one?
it's no, I think it's like 20.
I don't know that.
Why are you even a fan of Taylor Swift?
I'm a good enough fan that I'm supporting her at her concert.
Yeah, she needs it.
It's good on a local
I'm
artist.
doing charity right now. But actually, I don't know the song at all.
New Romantics. I will.
Tell me the lyric. You
Yeah.
should play it
Should we play it?
right now.
We'll get that on YouTube.
Yeah, wait.
No, that's not. It's not good. Okay.
Get copyright strikes.
Yeah. Continuing this here. We are going to.
What's the breakover?
Yeah, I think the break's over.
No, the break's not over. We have one more intro.
Oh yeah, we've got more intros. Hello.
Hello.
Hi. How's it going? We were doing intros. So what your name starts with V.
Yeah, my name is Vitharan.
Yes,
I'm kind of new to the AI meetups here. I co-founded Blockchain Indexer, and we're exploring building custom LLMs for like a ChatGPT experience for blockchain indexing and querying.
Nice. What's your favorite Taylor Swift song?
I don't listen to her.
Oh, I guess you should know that this is being recorded, so don't say anything.
Oh yeah, you're on record as the Taylor Swift hater now.
Jeez.
Oh, we're
Getting into it, I'm going to start from here, then I'm going to go through what this one means, and then I guess let's start it. We evaluate the performance of Gemini 1.5 Flash with context length window up to 1 million tokens on knowledge intensive questions answering, including multi-hop datasets, then Google Hotpot QA, music, and 2 wiki multi-hop QA, music, apologies. Additional results are provided in Appendix B and Appendix C. To manage the computational cost of extensive experiments, we follow those papers and sample 1.2 thousand examples from each data set for evaluation. The evaluation metrics include exact match, EM, F1 score, and accuracy, AC, in which the accuracy metric assesses whether the ground truth is located within the prediction. We sample the inference computational budget as L maxes, 16, 32, 128, 1 million, and 5 million tokens. For the parameter space of DRAG, we consider the number of documents. K is an element of 0, 1, 2, 5, 10, 20, 50, 100, 200, 500, 1000. And the number of in-context examples M ranging from 0, 2 to the 0 to the 1, all the way to 2 to the 8.
What does K represent here? I thought that would be the number of in-context examples, but that's apparently what M is.
K is the number of, no, K is the number of documents retrieved.
Oh, I see.
the
So like,
RAG
so the LLM submits a query and then you get back 0, 1, 2, 5, etc. documents.
Yeah, so if K
Okay.
is equal to 0, it's essentially just 0, I guess it's end shot, end shot prompting without RAG. Yeah.
So if they're both K is 0 and M is 0, then it's essentially 0 shot prompting, right?
Yes.
Okay.
The iterative, we further experiment with the number of iterations and up to 5. We compare the following baselines: 0-shot QA, where the model does not leverage any retrieved documents or demonstrations; many-shot QA, where the model uses varying numbers of demonstrations M without any retrieved document; and 3, retrieved augmented generation, where the model only uses K retrieved documents without demonstration. So that's what we're doing: Lmax, K, and M with the parameters, and N iterations for iterative. Yeah. Figure 4. Normalized performance versus effective context length across data sets. Each line represents a fixed configuration scaled by varying the number of documents. Red dots indicate the optimal configurations, with the dashed lines showing the fitting results. The observed optimal performance can be approximated by a linear relationship with the effective context length.
Did these guys just put the same damn graph again, but wider?
Yes.
No, they did.
Yeah.
Okay.
There's a fit line to it now.
It.
No, no,
yes.
there's a bit like before as well.
So if it lines
Oh, that was the one
You
we said,
can-
yeah.
Look at the graph again and interpret it a different way.
that
I hear.
Was there a there's a
In
minimum
fact-
page limit on the publication? What was it?
exactly.
That's actually not surprising. I think this is a worse graph because you can't see that the green lines approximate the line like a lot closer, as you can see in the other one.
Yeah. Yeah. I guess the thing to take note of here is the same thing that we pointed out before, where drag is better at lower effective context lengths and iterative is better at higher effective context lengths. What was, yeah.
I feel like this is really, really missing the re-ranking, man. Because like
Yes.
no one does RAG without re-ranking.
Yeah, exactly.
You're not a serious.
It
like,
does. That was something that seemed to be very interesting about this, and they said it as like a conclusion step. And it's like, okay, cool. Could you do that?
Yeah.
Yeah. So we report the optimal performance of each method with different maximum effective context length budgets by examining their performance with different inference parameter configurations. Why does it keep doing this? 4.2 overall performance. We report the optimal performance for different inference strategies in table 1, where we identify the optimal inference parameters for each computation budget Lmax. Some variants are admitted for certain Lmax because they do not scale to the corresponding context length. For example, the prompt for 0-shot QA cannot be increased, while the number of in-context examples for many-shot QA is capped at 2 to the 8, so neither scales to Lmax equals 32. Similarly, RAG does not scale to Lmax larger than 128K, and drag is limited by the LLM's context window limit of 1 million. Unlike QA and RAG baselines, the performance of drag and iterative consistency increased as we expand the maximum effective context lengths. More specifically, we observed drag and iterative scale better than baselines. Baselines like many-shot QA peak at 16K tokens, while RAG improves until 128K, after which performance plateaus. In comparison, drag and iterative can find optimal configurations to more effectively utilize test time compute, exhibiting superior performance and scaling properties. Performance of drag consistently improves until 1 million tokens, while iterative further enhances RAG performance with 5 million tokens of computation budget, while iteratively calling LLMs. 2. Drag excels with shorter maximum lengths, while iter-drag scales more effectively with longer effective context length. At 16K and 32K, drag typically delivers the best performance, while 128K and beyond, iter-drag achieves superior results overall, highlighting the effectiveness of inference scaling with iterative retrieval and generation. These results suggest that increasing Lmax is beneficial for RAG performance, with drag and iter-drag strategies each excelling at different scales. I think that is a good thing. I'm going to move on to the next page. The optimal performance exhibits consistent gains as the effective context length expands, demonstrating a strong linear correlation, which we term inference scaling laws for RAG. Combined with data set specific results, our key observations are the optimal performance scales nearly linearly with the order of magnitude of the inference compute. Such linear relationships suggest that RAG performance can be improved by increasing computation, allowing for more accurate predictions of performance while given available compute resources. The Lmax above 10 to the 5, iter-drag continues to scale effectively with interleaving retrieval and iterative generation. This aligns with our results in table 1, where iter-drag better utilizes computation budgets for effective context lengths exceeding 128K. Gains on optimal performance gradually diminish beyond an effective context length of 1 million. Despite dataset variations, the performance follows similar trends up to 1 million tokens. Beyond that, improvements from 1 million to 5 million are less substantial or plateau, potentially due to limitations in long context modeling. In summary, while gains are smaller beyond 1 million tokens, optimal RAG performance scales almost linearly with increasing inference compute through DRAG and iter-DRAG. I'm often I have a thing with long contexts because I find that they're often overhyped, especially the 1 million to 5 million are less substantial or plateau. But Google will still advertise all of their language models as 10 million contexts. But if you ever try to use the 10 million contexts, the performance does drop off for anything that isn't needle in the haystack retrieval. So asking a question about one specific example in the context, which generally is not what you're using a large context for. And this in a Google paper also sort of points that out, that very, very large contexts are not very effective.
I get ChatGPT conversation that goes so long that it gets confused about the things they say.
Interesting.
And
Yeah.
it basically contradicts itself.
It's not that it contradicts itself, but it starts bringing up things that are irrelevant and way early in the conversation, kind of when you throw in something.
Also, just if you're using Claude Pro for any reason, it'll be you're about to hit token limits,
Yeah.
start a new conversation soon.
Yeah.
It's also because using it, every time you send a message, it uses your entire conversation so far as well. So that means by starting a new conversation, you hit your rate limits less often.
Yeah.
I haven't really gone into how but there are ways around that, context caching and everything that Gemini does offer. So that every time you generate a new token, it's not recalculating the attention matrix and everything. For figure 5, there's RAG performance changes with varying number of documents and in context examples. 5A reports the average metric values across the data set, where 5B and 5C, each line represents the normalized performance of a consistent configuration with progressively increasing documents and shots. Here, I guess we see that with 10 to the 2, so to 1000 is sort of the optimal number of documents for drag and iter-drag. and then it sort of drops off. And number of shots sort of plateaus around 10 to the, I guess 10 to the, or somewhere around here, somewhere between 10 and 100. This here is sort of how they find their optimal the optimal level, where they're sort of doing a grid search on the number of shots and the number of documents that they do in each thing. And the reddest one, for example, here is like the one that has the highest number. And this is how they get the like dots. For example, like these ones here, it's just like the thing that ended up getting the highest result after doing this sweep of the number of documents and the number of shots. I want to go through EM, F1, and AC because that is sort of important. Accuracy, exact match is it needs, like, for an exact match to be counted, you need the exact prediction. If Barack H. Obama and the ground truth was Barack Obama, it would be an EM of 1. F1 score is a softer one where it's the overlap of the prediction and the ground truth. And accuracy is if the ground truth was anywhere in the prediction, it's counted as an accuracy of 1. And so they're sort of the different metrics that we're using here, just to point that out. Any questions, queries, comments?
Can you just go back and show the 3 things again? Accuracy and then F1 and EM.
Do you want to know what's crazy about these slides? I just asked Claude to generate the slides for me, and it generated me the React that then rendered in the thing, which is crazy because you can just do that apparently. Like it just ends up going and like this, and it just does this. It's crazy. It just
Right, so you vetted the paper first, like you uploaded the paper to the chat?
Yeah, but like if I just created a thing that wasn't created, it'll just generate the thing for me. I'm gonna render this because it's just rendering a React component. And then after you,
Probably the most practical part.
sorry,
The how-to on doing this is probably the most practical part.
that is true. And then here we go. We've got that rendered for you, and then you can publish that, and then put that in your thing. Which is why I've done this with futures now.
That's why we're here.
So
get that out?
you're just embedding that in.
You don't need to create slide decks for your job anymore. Claude has it covered.
Oh, we still need a big slide.
Don't tell anyone. Don't tell anyone.
They're not gonna find out.
Oh, wait, you're embedding the link or are you embedding the code?
I did this really cool thing where I took a screenshot of it because I'm not very high tech.
Got it.
Yeah. Yes. That is those parts. I didn't find many other things to be interesting in that apart from, yeah, this is sort of the big part of the paper, which is I'll start from the complete other parameter specific scaling. To gain further insights into the dynamics of drag and iter-drag, we grid search over different combinations of theta just being all of the parameters, and evaluate the performance. The results are presented in figure 5, where we visualize drag performance using heat maps. See iter-drag heat map in Appendix C. Additionally, we provide further results with varying numbers of documents K and shots M. In summary, scaling, retrieval, demonstrations, and more generation steps led to performance gains in most cases. Yet such gains vary by effective context length and method. In particular, we denote documents and in-context examples are not equally helpful. For a fixed configuration, increasing the number of retrieved documents K usually leads to more substantial performance gains, as evidenced by the differing slopes in figure 5. I think that this is sort of obvious that increasing the number of retrieved documents would probably, like, you're giving up more information as opposed to more examples. Like, I would imagine you don't really need to give more in context examples of how to solve a problem, because they're already fine tuned on like instruction following and everything. So I don't find this to be too groundbreaking. But two, the increasing shots M is more helpful for iter-drag. For example, increasing M from 0 to 1 rather than K is more helpful for iter-drag, possibly due to demonstrations that lead to improved in-context query decomposition and knowledge extraction. 3, scaling saturates differently for drag and iter-drag. An example can be found in the increase of M from 0 to 1, which results in significant improvements for iter-drag, but shows little impact on drag. Beyond the soft thresholds, further increases in K or M yield marginal gains, even as a result in results in performance declines. And for a given L max, the optimal theta depends on the method, metric, and data set, as illustrated in figure 5a and figure 8. The optimal combinations were sensitive to the metrics and located differently, posing challenges for performance modeling with respect to theta. In conclusion, increasing documents demonstrations and iterations can enhance RAG performance, but each contributes differently to overall results. As such, identifying the optimal combination of hyperparameters remains challenging. This is sort of the end of the interesting parts of this paper. They go into creating a formula that then like matches that the actual like line on there. But then this paper goes into the difference between the predicted, like these dots are the predicted the predicted like performance versus this part here, which is the actual actual performance, other way around. Yeah, proposed observational scaling law versus actual metric values. I don't think that this is too interesting. Yeah, you know, the number of documents that you have, the thing increases. There are particular ones that miss out, which you sort of expect. And I'm going to skip all of the ablations as well. If you want to see how close the law that they did, it's the predicted oracle. So the oracle is the actual actual model's performance on a particular benchmark, and the predict is what their formula ended up predicting, and we can see that it is pretty close with accuracy and like a lot of their it's very close essentially. And that is about that. That's the main takeaway from this paper, that you can predict the amount of documents and generation steps that you can use in a RAG pipeline.
Something occurred to me about this paper.
Mm-hmm.
What are the odds that it started off as like a marketing pitch for the Google really long context window?
Yeah. I mean, I think of most things that Google output are marketing pitches for their really long context window.
What are you insinuating about Google DeepMind? You think they don't have research freedom to research what they want? You're insinuating?
No.
It wouldn't be such a thing.
I mean, I think there's better ways to advertise long context windows than putting out a research paper that subtly mentions that.
But the whole research paper, it's creating a use case for long.
Mm-hmm. Yeah.
And it targets the audience.
Yeah,
Look, these tables right here, these might be the most useless bolded numbers I've ever seen. It's like, hey,
Yeah.
obviously, it's better than baseline. There. Well, if it wasn't, I'd be with you. Actually, it's like a tie on one.
Yeah. This one here, they take the smaller predictions from a smaller like context budget and then try to predict the larger ones. And you can see that in some ones like 100, when you're trying to predict the accuracy of a 128K with a 32K context budget, it ends up not doing very well. Like there's a 9 point difference here. And I think they gave
So what we take from that would be that your results may vary and they may be much better than the scaling laws they gave. Actually.
yes.
Cool. That's exciting.
Yeah, essentially. Going to the discussion part of it, which is the next part. In our experiments, we observed consistent benefits of inference scaling using DRAG and iter-DRAG combined with the computation allocation model for RAG. This approach enables the derivation of a nearly optimal solution for long context RAG given computation constraints. In the following, we discuss additional factors that may influence the scaling of long context RAG. Retrieval. One critical factor in improving performance of RAG lies in the quality of the retrieved documents. To study how the retrieval impacts final accuracy, we analyze retrieval performance and report the results across different document sizes in Appendix A. In all datasets, recall scores demonstrate improvements as the number of documents increase, approaching near perfect scores with large document sets, e.g. around 1,000. Despite consistent gains in recall, the results show diminishing returns on discounted ranking metrics like NDCG, indicating increasing distraction within the context. This trend is also evident in Figure 5b, where RAG performance peaks between 100 and 500 documents. Our observation suggests the necessity of refining retrieval, e.g. through re-ranking. They did it
This whole time.
to further optimize the document relevance, particularly in cases of complex multi-hop queries. Yeah, so they got there in the end, which is good. And now they are saying, yeah, so just to give some background, recall is essentially is the correct the correct document in the thing that you in the 1,000 documents that you retrieved, which you would expect it approach near perfect scores, because if you just get every document that exists, it's eventually going to the one's going to be there. The NDCG and there's another one that they use is essentially like, is the correct document ranked near the top of the 1,000 documents that you ended up like retrieving? And it turns out that it's not really often. And yes, so re-ranking is a real low-hanging fruit in this paper. Maybe that was just too difficult to implement or something, but I'm sure we will see another DeepMind paper that has re-ranking sometime in the future. Yes.
Like in the year.
How old is this paper?
This is,
It's 2 months old.
yeah.
So is this just a points grab?
It's like the season finale with it ending on a cliffhanger.
Is this a points grab? Like, did they know that re-ranking was gonna do it and they just they need volume? Because, publish or perish?
Possibly.
I think it just would have muddied the waters, would have taken too long, because they already had to grid search over like number of documents, number of examples, all the different methods. Like they probably just needed to show that their iter-drag can work and like just throw their hands up. And if AI were like a totally different normal science field, then like they probably would have included it, to your point, and like had a much more it would have been less about publish or perish for them, I'm sure, but I don't know.
Because everybody plays the game, right? You only do one thing per article, so you can get 5 articles out of an idea rather than one.
Yeah.
Yeah.
Exactly.
Because nobody plays that game, right?
Yeah,
Researchers in the room.
And the other problem about this paper, I think, is like their whole scaling laws are around effective compute, which like, how do you map that to a real world problem at all, ever? Like effective compute, like how do I know if I need 100 documents, 500 documents, 5 documents for a certain problem in the workspace? Like, and then how re-ranking interacts with that is just ends up being like this insane search problem. So it's like, it's cool that they showed the relationship, but then how useful is it actually?
yeah. I guess the thing that is the most interesting about this paper is this here. Alternatively, iterative retrieval, as seen in iter_drag, improves recall performance by using simpler, straightforward subqueries to collect additional context for each intermediate answer. In summary, retrieving more documents improves recall, but does not necessarily lead to better generation quality if the documents are not effectively rank or filtered. This highlights the need for retrieval methods that dynamically adjust to minimize relevant content, which I guess is something that they're probably going to release in another research paper. I don't know.
True.
That is essentially the end of the paper. There's not a bunch more on that. We can go through a whole bunch of other, like, the same diagram, but it's just slightly different color. Yeah.
And
To go through the prompt examples while I'm getting drinks.
These ones here.
Yeah.
But does anyone do RAG stuff or things here?
Things, yes.
That's what the
You
lawyer.
do things.
I do things.
That's great.
I know my work is mostly like around embedding, so there is a bit of RAG component, but like I have never had to take so much document. I don't need like 1,000 documents to search.
So like re-ranking or anything isn't a thing that you.
Not really, like at least not for the use cases that I'm working with.
Gotcha.
So
What do you use embeddings for?
embeddings, so this is for e-commerce product catalog, so it's just like grouping and searching kind of thing, and then, well, it depends on like the underlying use case, downstream usage. But yeah, that's basically the concept. But yeah, like the product catalog, again, like I have the opposite problem where I don't have enough data and I need to,
Oh,
make it more.
right.
Yeah.
Gotcha.
Yeah.
Right.
Sorry.
There's quite a few use cases where we use RAG.
Do you do re-ranking?
I think so.
Oh, interesting. Well, maybe that's a
To do. Yeah.
yeah to do exactly. Yeah. This yes.
I just want to mention like, Dave usually comes to this meetup. He's here today, but yeah, I'm exploring things with him, but with setting up a custom RAG pipeline to basically we have like indexer that's 85,000 lines of Rust code, and we need it to build public API documentation like an SDK. We're exploring that, but
is that for the government data? Is that Dave?
it's for blockchain indexing.
Oh, right.
Yeah, but we are, there was one use case we came across where a company wanted us to index legal documents. So we're building like, we're gonna have to build a GraphQL API for that.
Wait, so but like you're indexing blockchain
Yeah.
data to then, and what are you using LLMs for?
So we wanna, so right now, like, we want to explore speeding up development for our SDK because we don't have like the public API documentation right now. So if developers wanted to use our indexer, it's like we have to integrate for them.
Right.
So that's one area we're exploring, and
Like creating dev docs.
Yeah.
What's the input? So like, Wait, so you already have the API and everything, and you're generating docs to the API?
We don't have the API yet. We have a bunch of Rust code that we're trying to build the documentation for.
Gotcha.
Yeah, that's one area we're exploring. And then the second area is instead of having like a developer write the GraphQL, like whatever the script is, the query code, you want to have like a ChatGPT type of experience where I can type in, give me the top 10 wallets holding this token. It'll generate the script for me. And then submit the query and then retrieve the data.
Which is interesting because the other paper that we were going to cover is a Agora Lab. Is it this one? No, it's not that one. Which is Agora Protocol, which has essentially it's like about creating
LLMs that talk to each other.
LLMs that talk to each other and formalize protocols as the more queries happen. And this like really decreases the cost and increases the reliability, because then you like create an API between two language models that are talking, and then all of a sudden it skips out the language model if you're always getting the same data.
Have you looked into Swarm?
Yes, I have looked at Swarm. Sorry.
Do you know like the differences between this one and that one at all?
Swarm is. I haven't actually used Swarm. Swarm. It is Swarm communicates in RAG, which is quite interesting.
The big thing, or get the novel thing about this one is every LLM that looks back at its history to identify, okay, these are the questions that I keep having, the conversations I keep having with this other LLM, and then it'll ask to, yeah, here's the paper. Go in the appendixes of the protocol, which I thought was a good way of.
Yeah.
No, it's.
Oh, the conversation that's like between Alice and whatever.
Do I go?
This one here.
Sure, yeah. So basically it'll do that extra level of kind of thinking about its own thinking, and it'll negotiate a JSON based protocol. And then after it's negotiated the protocol, it'll just give, okay, this is the protocol ID I'm using. Here's my date and location just as JSON objects. And then it just expects the JSON response. So it can be an LLM without having the LLM stuff. They just invent an API.
Oh, this is where LLMs outperform the humans. And they were able to negotiate and come up and follow the protocol.
That's the whole thing, is it's kind of coming full circle, and they just created a weather API, but it's all happening through LLMs. Or like they have an example of like a taxi booking or like a hotel booking or whatever you want to do. And the idea is like it's enough.
It's interesting.
Yeah.
So at this time, like, there's no way LLMs can communicate with each other if they're what's ChatGPT, Llama.
So that's what they do
can,
here,
but
but
there's
in
a
general,
lot of
not yet.
yeah, there's a lot of wasted tokens in that, because if ChatGPT is asking another agent for the weather all the time, they're always consistently like communicating with extra tokens, like they exchanging pleasantries and all this stuff. And instead you can just generate JSON and then just like even just generate a piece of code that then hits the downstream API. And so then the other agent can just hit that API instead of going to the language model.
But did they talk about like how much they go back and forth and negotiate something like that?
There's another chart that says what percentage of the tokens are all used for.
Like this one here.
No,
Can they use binary protocols, or do they just use the human
in
understanding?
here they were just doing JSON.
Anyway, this is the other paper that I decided not to do for some reason, but yeah,
So do it sometime.
that's true.
Maybe I'll do it, and
Uh,
I'll ask it Australia.
Yeah.
Maybe.
A little bit. I'm not sure. Yeah, so it negotiates the thing, and then the next time that it has a protocol that it wants to check if it can use, it uses like the hash of the protocol, and so then it can look up the thing.
It's so crazy.
Yeah.
And when they say PD, that's a protocol doc, and that's just basically like a markdown developer docs, like we would think about it. So it just says like, it's a markdown document, says this is the input I'm expecting, this is the output you'll get back.
And the PD is generated as well.
And then, yeah, it's all big up. It's basically the conversation that they have that might be summarized or condensed.
Yeah.
Logical definition.
Yeah.
Yeah.
So that's the thing. I'm gonna,
So
yeah,
we're at 7:35 now. I wanted to take, I don't know, 20-ish, 15 minutes, just to kind of see what are you guys interested in seeing? Like, some of you have been to a few of the paper readings. Are they particular topic more interesting than others? What would you like to?
would it be interesting to do a paper submission the week before? And so when we get to Monday, we can have a paper that everyone wanted to read.
Yeah, I mean, Josh is very good at picking papers. He's all them so far, but if anybody wants to propose anything or present or.
I think that's a good idea. We can vote on the papers.
Yeah.
And we can pre-read it as well.
Yeah, that also works.
Yeah.
I saw today I saw a paper called The Surprising Effectiveness of Test Time Training for Abstract Reasoning from MIT. So like the same one as the DeepMind one.
Do you have the archive number?
See if I can pull it up.
Oh, cool.
Nice.
3 hours ago. Nice. It's great.
That's the one.
Wait, 3 hours ago? What? Yeah, I saw it today. Jesus. So, yeah, I mean, you saw it today. I was expecting maybe it came out last week.
No,
or
it's
you're like
definitely
waiting
something
at
else.
Jesus.
That's probably on the
Language models have shown impressive performance on tasks within their training distribution.
Oh, this is the
Often
ARCS challenge.
Struggle. Oh, no, wait. Often struggle with novel problems requiring complex reasoning. We investigate the effectiveness of test time training, updating model parameters temporarily during inference, using a loss derived from input data as a mechanism for improving models' reasoning capabilities, using the abstract and reasoning corpus ARC as a benchmark. Through systematic experiment, we identify 3 crucial components for successful TTT: initial fine-tuning on similar tasks, auxiliary task format, and augmentations. Per instance training, TTT significantly improves performance on ask tasks, achieving up to 6x improvement in accuracy while compared to base fine-tuning models. Applying TTT to 8B parameter language model, we achieve 53% accuracy on ARC public validation set, improving the state of the art by nearly 25% for public and purely neural approaches. By ensembling our method with recent program generation approaches, we get state of the art public validation accuracy of 61.9%, matching the average human score. Our findings suggest that explicit symbolic search is not the only path to improved abstract reasoning in neural language models. Additional test time applied to continued training on few shot examples can also be extremely effective. Yeah, this is sick. This is really cool. Does anyone know what ARC is? Like, have you heard? ARC AGI is a benchmark made from this guy who works at Google who doesn't like LLMs, and she's proving that they're not very good. It's abstract reasoning in a, like, it's a bunch of visual puzzles, and you're basically given an input and an output, and you're given like a bunch of examples, and then you need to like complete the example. And so here we would have, like, we would try to do this or this here, and we can see that the pattern is sort of the blue ends up going into the corners of the other ones. One of the things that one of the reasons why language models don't end up doing very well at this is because it takes a lot of abstract reasoning to be able to actually complete this. And then, like, we got that right, but if we had another one here and we submitted our solution, it would say it's wrong. One of the things about this is because it's so abstract in the different possible combinations that you can have with this, language models aren't very sample efficient. And so giving them 2 or 3 examples of a new pattern, they're not very good at generalizing to that pattern. As we saw in the Apple paper, because they're not very good at like learning from few examples, they end up not being very good at this, these type of reasoning tasks. 53% is really, really big, and 61.9% that they got to is very, 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 very high. So that's cool. We should totally do this next time, maybe.
That's good.
Good call.
That seems like a typical IQ problem.
Yes,
Yeah.
they're not very good at IQ problems.
I like it.
Correct.
Yeah.
But 62%, I know lots of people that are way below that level.
Yeah. That's true.
Like they are intended to be like easily gettable. Like this one, I believe like every challenge is as easy as filling out that box, which hopefully most people can get.
Okay, so they're not true IQ problems of.
No, they don't get that much harder than this, is my
I think
understanding.
there are ones that are quite,
I think
like,
that's-
go previous, go, that's 1 to 6.
Okay, are we testing out? Are we
See, like,
actually
That's,
language?
I would say that's hard.
Okay, no, that's not.
Yeah, that's fair. That is harder.
No, it's not even that much harder.
But it's still like the whole,
hours, but then after that,
complexity. Correct me if I'm wrong, but the intent behind this was to make a benchmark that like almost all humans could get if given like time and resources. But
Yeah,
yeah, no, to his point, there definitely are people.
it's yeah. I think this I tend to think about it as like intelligence being a thing of like sample efficiency, and language models are good at remembering stuff and copying things that look like the solution, but they're not very sample efficient. That when you give it new things, they're not very good at like. Then the reason why they're not very sample efficient is because they're not very good at thinking of things at a very highly abstract level. And so when you give it something like this, it can't do abstract reasoning on it because it hasn't seen an example like this before.
how do you even give this to now?
JSON, photos, something like that.
You gotta try this with iter-drag.
That's
Intersect. Do you think it's somehow it's
Yeah. Is everyone cool for doing this paper next week?
yes.
Cool. Sick. I think this is a better idea because sometimes if I'm just reading the papers and like doing the papers and everything, but there's like a billion different papers to go down, that having a set choice of everyone agreeing on a paper means it's a lot easier for me to prepare as well. So that's a good idea. It's
No.
7:40, which is the earliest we've finished because we sort of skipped a lot of that paper, which is probably a good thing. So yeah, that's it for that's it for that.
Question about another paper.
Yes.
And out of book 3B. Which is, I'm trying to find the name.
The thing, AlphaFold papers, yeah. Some of the DeepMind stuff ends up being quite mathematically intense, and especially because it's not like language model papers, LLM papers, and everything end up being not a whole bunch of overview to like. Yeah. But yes, I can look into it and see what the thing is. One of the things with papers that aren't language model papers is that they end up requiring a lot of background that a lot of people end up not having. But I'm going to look at it because I am interested in doing non-LLM papers, but it's just a matter of figuring out how to deliver it effectively at a level that people understand and get value from.
If you do end up doing that, I can give you a demo.
That would be so cool. Yes, of course.
Yeah,
They have the paper, like the code open.
it's open source. It's like at the server and like.
Okay, yeah.
Are you on top of book 3?
Okay, this would be so good.
A few months ago or weeks.
I think it was released today or yesterday.
No, the other thing.
When I look at the AlphaFold 3 on GitHub, it shows the initial release was 14 hours ago.
Okay.
So
That might
they
be,
didn't publish the code initially a few
Yeah,
weeks
they
ago, but now they probably publish the code, of course.
it's not, this also, our initial release of AlphaFold 3. Wow, interesting.
Yeah, so they didn't publish the code with the paper first.
Gotcha. Yes, that would
They
be,
wanted to clean it up or what?
yeah, I
Who
mean,
does anything? Once the paper is published, you move on, like.
Oh, it's because they wanted to quietly release the protein prediction tool.
They had to take.
We'll use technologies and such.
I mean, it sounds like they might want to sell this technology at like drug labs, because it says you can only use it for non-commercial use, so sell it to all the big drugs, sell it to big pharma, so you get that money.
I was reading on a cybersecurity blog about